Okay, so we're going to be looking at length, area and modelling, still talking about coordinate geometry, still looking at graphs, we're looking at the length of things, area of shapes on a graph, and using lines on a graph to model, which mean like model real life kind of situations. So first of all, let's draw a sketch and see if you guys can figure out just how we're going to work out the length of some lines. So if we have some axes, I'll have 2 points again, so again x1, y1, coordinates of point 1, x2, y2. There's our line, and we want to work out the length of this line. So very quickly, have a think, see if you can figure out a way we could measure the length of this line using these two sets of coordinates. If you're a bit stuck and you need a hint, maybe that will help you. So what we're going to do, if we can work out what this length is, and this length, we can then use Pythagoras to find out the length of the hypotenuse of this triangle. So this length is the difference in the y coordinates, so this is going to be y2 take y1. This length is the difference in the x coordinates, so it's going to be x2 take x1. And we know Pythagoras, a squared is b squared plus c squared. So if we put it all together, we can say the length of the line is the square root of y2 take y1 squared, so that's that length squared, plus x2 take x1, which is that bit squared. And that gives us the length squared, so we square root it, and that's our length equation. So that is the length of a line, and that's another equation we need to learn. But you can remember that it's just Pythagoras to do with these lengths here. So, example. So find the length of the line segment joining 2, 3 and 5, 7. So we're just going to say this is coordinate 1, this is coordinate 2, and then put these into the equation. So if you want to pause it and get it going on your own, go for it, otherwise I will do it now. So length equals the square root, y2 take y1, so that's going to be 7 take 3, plus x2 take x1, so 5 take 2. So we say length is the square root of 4 squared plus 3 squared. Get rid of all that. So it's root of 16 plus 9, which is root 25, which gives us the length of 5 units. Brilliant. Alright, next example. So next bit, calculate the length of the line segment joining 5, 0 and minus 2, minus 1. So pause it, give this one a go yourselves, again using that equation. So minus 1 take 0 squared plus minus 2 take 5 squared gives us the square root of 1 plus 49. Which is root 50, which gives us root 50. If you wanted, we could use surds and then split this up. So we could say that's the square root of 2 times 25, which is root 2 times root 25, which gives us 5. Root 2 is our length. Right, next up, areas. So areas, basically you can be asked to find the areas of shapes that you make on graphs by joining lines or line segments together. So, e.g., if we had a few points here, so we're going to have 0, 4, 0, 2, and we could say those 3 points make a triangle. And we could be asked to calculate the area. So, area of a triangle then. You should remember from GCSE, area of a triangle, half base times height. So looking at this triangle, the height we can see is going to be that length. And if that's the height, then the base is going to be that length there. So if we can work out how long this line is, times it by how long this line is, and times it by half, we can work out the area of this triangle. This is quite an easy one. So 0 minus 3, we know the height there is going to be 3. And we need the length of this line. Well, you could use the length of line equation, but because they're both on the y-axis, we can just say, well, that's 4, that's 2, so the whole length, I should actually say minus 2, shouldn't I? The whole length of this is just going to be 6. But if you use the length of line equation, you'd still get 6. So half times 3 times 6 is our area, so we're going to get an area of 9. Right, so using that and using what we've done already, we're going to try and do a pretty massive question that involves everything we've done so far. So I'd like you guys to try this, pause it and try it, and then I'll go through it with you. Okay, so pretty big question, as I said. This kind of contains a lot of different aspects of what we've done so far, and this is very kind of similar to stuff you can expect to come up in the exam, because they'll ask you questions about everything. So, first of all, find the equation of the line perpendicular to this line, which passes through the point. So that's what we did in our first and second video lectures. Part B, find the coordinates of the point at which these two lines, this one and the one you find is your answer to intersect. And part C, find the area of the triangle bound by the two lines and the y-axis. So if you want to pause it, give that a go. It'll probably take you about 10-15 minutes this one because there's so many parts to it. But pause it and I will start going through it here. You can mark it as you go if you like. Okay, so part A. We want to find the equation perpendicular to that which passes through that point. So remember, perpendicular lines have negative reciprocal gradients. So our gradient of the line we're looking for is going to be minus a half. So we've got the gradient, we've got the point, so let's put them into the line equation. So remember, y minus y1 equals m x minus x1. So if you put all that together, we get y minus 28 equals minus a half x minus 4. So if we expand, rearrange this to get y equals. So I just expanded my brackets. Now I'm going to add 28 to each side. So you get y minus a half x plus 30. So there we go. Alright, part B, find the coordinates of which the lines intersect. So it's where this line meets that line. So as we did, it's going to solve them simultaneously. So I'm going to set y equal to y. So we get 2x plus 5 equals minus a half x plus 30. So if I take 5 from each side, 2x equals minus a half x plus 25. I could then add half an x to this side if I wanted to, so we get 5 over 2x equals 25, times by 2, and divide by 5. So x is 10. Now we need to substitute that back in to find y. So we know y is 2x plus 5. So x is 10, so y is 2 lots of 10. 2 lots of 10 plus 5, so y is 25. So the coordinates are 10 and 25. Okay, last bit then. So find the area of the triangle bound by those two lines and the y-axis. So in order to do this, it's going to help if we can roughly sketch our two line equations. So we've got 2x plus 5, so that's a positive gradient going through 5. And we've got a negative gradient going through 30. So I've drawn an awful sketch and stop that down. Okay, so axes. So we've got a positive gradient, oh, we lost it. Positive gradient going through the y-axis at 5. And a negative gradient going through the y-axis at 30. We know that they meet each other at 1025. So we've got the area of this triangle. So again, we can see the height of this triangle is going to be from 0 up to 10. And the base of this triangle is going to be 30, take 5, 25. So the area of the triangle, half base 25 times the height 10, which is going to give us an area of 125 units squared. Okay, last bit for today then is talking about modelling. Modelling is a topic that's going to come up throughout the A-level. There's loads of questions about modelling, and it's basically being able to apply the maths we do to real life situations. Okay, so first of all with modelling, we need to talk about something called proportion. So proportion is when x and y increase at the same rate. So, for example, we can say y equals k times x. So this means that y increases with x according to this constant k. We call that constant a constant of proportion. So we could say that for every unit increase in x, y increases by k. So in other words, in this case it's the gradient. If x goes up by 1, y will go up by k. So it tells us what the increase in y is when we increase x. It's very similar to our gradient. Alright, so about to write up a massive block of text to do with modelling. So I'll copy this up. If you guys can copy it down into your notes, and we'll have a quick talk about what it means. Okay, so models are attempts to represent real life situations using mathematical concepts. So models are our way of turning stuff in real life into equations that we can solve and predict things about a real life situation. However, it is impossible to 100% mathematically model real life. Obviously, otherwise we could predict the future. So we make assumptions to make the situation easier to create a model. So we assume things, we kind of say things don't count, don't matter, in order to make real life a little bit easier to make a mathematical representation of it. What that means is we're never going to be totally accurate, but we can make some pretty good predictions about real life situations using maths. Generally, the better the model is, the more complicated it gets because it has less assumptions. But you're never ever going to be able to 100% predict what's going on using mathematics. So let's try an example. Yeah, this example is about my band. So yeah, let's see what happens. Right, so 3 parts to this. So we're told at the beginning that my band had 200 fans in 2015, and in 2018 we had 2,600 fans. This is all real data from Facebook about my real life band. Part A, write a linear model for the number of fans, which we're going to call F, T years after 2015. So that's told us we need to use the letter T for how many years after 2015. Part B, how many fans will the band have in 2025? And C, give one reason that the model might not be realistic. So if you want to try this, go for it. We're using the things we've done online so far. Although now we're talking about real life situations, we can still use the mathematical equations we already had to turn this into an equation. If not, watch and I'll go through it with you and you can write it down as an example. So first up, the first year is 2015. So 2015 is the first year, therefore when t equals 0, because it's 0 years after 2015, f, the number of fans, is 200. So that's the first thing I've taken from the text that we've been given. And basically we can use this as a coordinate. So we can say when t is 0, f is 200. Time is the thing that's changing, so time is going to be on our x-axis. We call it the independent variable. So we can say as a coordinate, this is 0, 200. The other point we've been given is in 2018, we had 2,600 fans. So we can say that it's going to be now 3 years, so we can say 3 is our next coordinate, and our x-axis, our y-axis is going to be 2,600. Cool. So first thing I want to do is work out the gradient so we can come up with an equation for f equals something t plus something. So we're trying to work out the gradient and the y-intercept for this equation. So we can work out the gradient just by doing y2 take y1 over x2 take x1 like we had before. So it's going to be 2,600 take 200 divided by 3 take 0, which gives us a gradient of 2,400 over 3, which is 700. So my gradient, 700. What's my y-intercept going to be? Well, if you think about a graph, y-intercept is the y value when x is 0. Well, our initial value is 200, so our graph is going to have 200 there and a gradient of 700. So as an equation we can say f equals 700t plus 200. So that's our model. It tells me the number of fans my band has, 700 times the number of years after 2015 plus 200. So that's part A done. Part B, you might want to try on your own. How many fans will the band have in 2025? Well, 2025 is going to be 10 years later, so we can say for part B, let t equal 10. So our equation is going to say f equals 700 times 10 plus 200, which gives us 7,000 plus 200, 7,200. So it's a prediction based on this model, based on these two data points, for how many fans the band will have in 2025. And part C, give one reason it might not be realistic, is because we don't know about this data whether it's the same increase per year. We've assumed every year the band gets 700 extra fans, but we don't know what's going to happen, so we don't know if it's a constant linear model. So it might, no evidence to suggest the increase per year is constant. So silly example, but that's an example of how we can use mathematical models, equations, to predict real life situations. And I'll let you know in 2025 whether the band does have 7,200 fans or not. Cool, right, so you can move on to the quiz for this topic, and I think there's one more short lecture left on coordinate geometry, and then we'll be moving on to something else for next week.